So in this example, we are going to solve an initial value problem given by this differential equation, derivative of y with respect to x equal to 3x plus 2. But we also have given an initial condition, right? So since this is an initial value problem, we'll have been given an initial condition. Or let's say it in this way. If we have a differential equation given with an initial condition, that problem is known as initial value problem. So how do we solve this initial value problem? So since we have given two conditions, right, so one is differential equation and one condition given over here that satisfied by the function. First of all, what we try to do over here is try to come up with a function or a set of function that will satisfy this differential equation, which is known as general solution. And among those solutions, we just try to come up with one particular solution that satisfies this condition. So that's the strategy works. Okay, so because of that, we'll first focus on finding the general solution first. So find the general solution of this differential equation. So there are several techniques we can apply to find a general solution of a differential equation, but on this particular case we can do it very easily because this is one of the simplest differential equation. So why do I call it simplest? You can look into here. We have given this as a something like a form of derivative of y with respect to x is equal to some kind of function of x is given, right? So that means we are just looking for some y, that's right, looking for some y or some function whose derivative is f of x or whose derivative is 3x plus 2. So how would you figure out a function whose derivative is something? All the time we cannot figure out easily, but for some of the function we can just find the entire derivative, right? So on this case, so if you are looking for, let's say, something like a function whose derivative is f, right, then to find y over here whose derivative is f, you just need to do the entire derivative of f of x or find the entire derivative of f of x and see if we can find that. If we can find that, done, that's it, right? So that's the solution of this differential equation. So if that is the case, let's work over here and then try to see if we can just find the entire derivative of 3x plus 2, which we can, I believe, right, and figure out the solution. Okay, so our task was to get the general solution. So to do that, what I'm trying to do over here is, since this is our differential equation, to find the, which is something similar like this format. So to find y, what I'll just do is find the entire derivative of 3x plus 2. So if I just find the entire derivative of 3x plus 2, which I can, sometimes we cannot find the entire derivative of that kind of function, but right now we can. So let's just try this. So entire derivative of 3x is 3 times entire derivative of x would be 1/2 x square, right? And then plus entire derivative of 2 is 2 times x plus some arbitrary constant. So if that is the case, this is what I get. I get a y function, right, as a function of x, which is given as 3/2 x square plus 2x plus c. This is known as general solution of the differential equation, because if you find the derivative of this, you exactly get 3x plus 2, right? Or this, no matter whatever is the constant, all of these function satisfy this differential equation. But I need to now solve this initial value problem. That means also satisfy this initial condition. To do that, I just need to figure out among these infinitely many functions, I just need to find one which satisfy this condition. That means the function that I need to figure out, the particular function that I need to figure out, when we evaluate at 0, its output must be 2. So to find the particular solution, I satisfy that particular condition. Okay, solution. So to find the particular solution, let me substitute this condition. So we have given here on this condition, it says that when y evaluated at 0, we get 2. So why don't I evaluate this function at 0? So when I evaluate y at 0, I'll be getting what? over here replacing x by 0, we get 3 half 0 square, right, plus 2 times 0 plus the constant is as it is. But according to this condition, it say that the y at 0, right, has to be 2. So if that is the case, I'm substituting that condition. So since y at 0 has to be 2 is equal to, this is 0, that's 0 plus c. So we get 0 plus 0 plus c, which implies the value of the constant is actually satisfying that particular condition is 2. So that is the constant. But what is particular solution then? The particular solution would be, so whatever is over here, which is y equal to 3 half x square plus 2x, right, plus that constant will be now whatever we have just figured out over here, which satisfy the initial condition, right? So 3 half x square plus 2x plus 2 is your particular solution, right? So this is the solution of the initial value problem. So whatever we have received here is the solution of this initial value problem, because this satisfy the differential equation and it also satisfies this initial condition.